Alright, welcome to phase 2 of factoring expressions, and then this time around we're factoring quadratic expressions. Last phase was only binomials. This time we're going to do trinomials. Tri means 3, and so we're going to have 3 terms. 1, 2, 3 right over here. The highest exponent is a square, and thus it is a quadratic expression. It's parabolic. We are going to deal with, I guess, something a little bit simple first, where your a value, your coefficient, is equal to 1. So I'll show you some of the steps for that. There are 11 examples in this video. It's a lot just because I want to be thorough with these kind of phases, so you can end up teaching yourself like that, etc. So let's get started with the 11 examples. Part 2 is going to be practice problems if you decide to go on to more of that stuff. All right, well, let's just get down to it. Example 1, all of these directions are just going to be to factor. You have to notice first that the coefficient in front of the x squared, the a value, is a 1. It is a 1, okay? And so if it is a 1, then we can follow these steps over here. Let's go. 1x squared plus 9x plus 20. You could problems are also going to be in this kind of form, x squared plus 9x plus 20, and usually will be in this form. But you just got to notice that a is equal to 1. You're going to deal with the last number first. You want to list down 2 numbers that multiply to the last term. So let's start off with that first. What 2 numbers multiply to 20? That's what I mean. We can go 10 times 2. Okay. We can also go 5 times 4. Don't forget, sometimes also 1 times 20 works as well. Okay. All right. Now that we've listed those 2 numbers, from those pairs of numbers, you're going to circle one that adds up to the middle term. Our middle term is going to be 9x. So, well, 10 plus 2 is equal to 12. Nope. 1 plus 20 is equal to 21. Nope. This is it. It's going to be 5 and 4, because when you add them up, it's going to equal to 9. Okay. So the next step is you're going to make factors. Factors are 2 parentheses. So these are what's called factors, and you're just going to place an x over here. You're going to place an x over here, and then after that, your pair that worked, you can go plus 5 since it's a positive 5, and then plus 4 since it's a positive 4. And you can just leave it just like this. For right now, it doesn't matter. You could also have put the plus 4 here or the plus 5 over here. It's okay, so or x plus 4, x plus 5, and that is okay. It's a little bit simple. I hope so. If you want to check your work, especially if it's like maybe like a quiz or test about factoring, you can do what's called FOIL. On the next round, I'll do what's called box method, and that's what I usually use for my algebra class at Kailua High School here in Hawaii. Foiling is just first, outer, inner, and last. So FOIL, x times x is x squared. Outer, x times positive 5 is 5x. Inner, 4 times x is 4x. And then L stands for last. 4 times 5 is 20. And usually these are going to be, you can combine like terms. So it's going to be x squared plus 9x plus 20. And that is actually the problem that we started off with anyway. Yeah, x squared plus 9x plus 20. Okay. So when we FOILed, it checked out. So this is really your answer over here. So our answer today, we need to have 2 factors, 2 parentheses. Okay. I usually say, any questions, class, after this, but no one's in front of me. So I'm going to keep going on example number 2. Remember, there's 11 examples today. This is how I usually teach. I like to give a lot of examples, and that way I cover most of the scenarios, or at least all of them. Okay, there's a 1 in front over here. So we can go down to what I've taught you guys. What 2 numbers multiply to positive 10? We have 5 times 2. Okay, don't forget we have 10 times 1. So that's another possibility. Which pair though adds up to 11k or 11? If we were to go 5 plus 2, that's going to be 7. So that's not going to be it. Okay, so sometimes this pairing of the 10 times 1 will usually work, and some students tend to forget that. Okay, because 10 plus 1 is equal to 11. All right, your two factors now, you'll just put k over here, you'll just put k over here, and then after that it's going to be plus 10 and then plus 1. Okay, this will be the last time I will check the work, and then after this example, then I'm just going to move on to just the answers only. Over here at Kailua High School in Kailua, Hawaii, we usually I like to do what's called box method, where we draw a box like this. It's a little bit more structured for my students, because sometimes when you do FOIL, you tend to forget some of the negatives and positives. It's okay. K plus 10 is over here, and then the k plus 1 is here. Okay, it's essentially the same thing, and then you'll see why. Then you're going to multiply inside the boxes. K times k is k squared. 10 times k is positive 10k. 1 times k is 1k. And then 1 times 10 is going to be 10. Okay, and then afterwards you are going to multiply, add these two because they're like terms. It's very similar to FOIL, you guys. So this is going to be k squared plus 11k plus 10, and it does work out because that's the original problem that we started off with. So this is your answer, these two factors, k plus 10 times k plus 1, or you can even switch it. Okay. Any questions? Sorry, it's already automatic for me to just ask that. Any questions during, because I teach at Kailua High School for now anyway. Well, let's see what happens. Okay. Let me just do examples 3 and 4, and then we'll wrap it up. Then we'll do a little bit more examples, of course. Okay. There's a 1, and so let's figure this one out. Okay. What two numbers multiply together to make 54? We have positive 9 and positive 6. The only problem with this one is if you go 9 plus 6, that equals to positive 15. And what we want is a negative 15 over here. So we probably don't want the 9 and the 6. If for positive numbers, you can have two positive numbers. Don't forget, you can also have two negative numbers, because negative times negative is equal to a positive. And we're going to select this because negative 9 plus negative 6, that equals to negative 15 for that middle term. Okay, so your factors are going to be r minus 9 times r minus 6, or you can even switch it. Okay, a switched is, okay, I'll just remind you guys, okay, or r minus 6, r minus 9 is a-okay. Okay. Let's do example number 4, and then I'll wrap it up and for the first part of this video, and then we'll move on to some other things. Example number 4. Okay, 27. What two numbers multiply to 27? We have 9 times 3. Don't forget we have 27 times 1, because sometimes that could work. The only problem, again, just in example number 3, is we have a negative and we want negative 12. Right now, 9 plus 3 is equal to 12, positive 12. We don't want that. 27 plus 1 is 28. We don't even want, okay? We probably most want both negatives, okay? Negative 9 and negative 3, because then they add up to negative 12. So your final answer is going to be x minus 9 and then x minus 3. Okay, I'm already about a little bit over 8 minutes of this video, so I want to wrap it up on this first part of phase 2, part 1 of 2. So really, if your last term, your last number is a positive number, so just as a small summary wrap up, you have two options, yeah? So say for example your last number is a 6, you can either have both positive numbers, okay, 3 times 2, 1 times 6, or both negative numbers, negative 3 times negative 2, negative 1 times negative 6. And usually the middle term in that case will kind of signal you like, hey, maybe we want two negatives instead, just like on the last two examples. So just a small reminder to just keep that in mind, okay, if your last term is a positive number. What if though, if the last term is a negative number? And then that's what I want to go over on these next 3 examples, okay? So I've kind of scrunched up 5, 6, and 7 over here. Let's just go from left to right. What if, though, you have a negative number, negative 35? Okay, when you have a negative number, you can't have two positive numbers or two negative numbers. So your first pair will be 7 times negative 5. One has to be positive and one has to be negative, because a positive times a negative is a negative number. Okay, so that's the difference if you have a negative number as your last term. Another variation to this is also negative 7 times 5. These are two different pairs. Okay, one is negative, one is positive. But we only want the pair that adds up to positive 2. And I believe the first one adds up to positive 2. If you want to calculate that in your head or in a calculator, 7 minus 5, that's positive 2. So then your final answer, your two factors are going to be m plus 7, because it's positive 7, and then m minus 5. Okay. All right, example 6. Same thing, negative 10. Okay, well, we have 5 times negative 2, because one needs to be positive, the other one needs to be negative, because it's a negative number here. Well, what's another combination? Negative 5 times positive 2. We can also keep listing down some things, 10 times negative 1. But I don't want you listing down stuff if you already see what we need. What we need is a negative 3, and then one of these pairs adds up to a negative 3 already. And it's going to be negative 5 and positive 2. They already add up to negative 3. Okay. So it's going to be v minus 5 and then v plus 2 for that, because it's positive. Okay, last example for this part of the section, and then we'll go over a little bit more. Negative 30, the one pair I can think of right now is 6 times negative 5. We can also go negative 6 times 5. Remember, one has to be positive, one has to be negative. But when you put them together, when you add them up, this is going to be positive 1, this is going to be negative 1. We want negative 7 over here, so this is probably not the case. We're not going to use these. Another pair I'm thinking of are the 10s. So we can go 10 times negative 3, negative 10 times positive 3, and I believe we do have a pair, and it's going to be this one over here, because they do add up to positive 7. 10 plus a negative 3 will be that. Okay, so your two factors are going to be p plus 10 and then p minus 3. All right, so in a small summary, and then we'll get to the next examples a little bit later. If your last term is a negative number, okay, so like on the last 3 examples, like say for example we have negative 6, one has to be positive, okay, one of your numbers in the pair, and the other has to be negative, because a positive times negative is a negative number. So just be careful with that, okay? As opposed to, I want to give you guys back that other summary again. If your last term is a positive number, you have two options. Either both are going to be positive, or both are going to be negative. So there's a big difference with that, and some of my students still have a little bit hard time at the very beginning of this type of lessons, and then you guys will eventually get better over time. So just be careful with these last terms. Positive number, 2 positives, 2 negatives. A negative number, one is positive, one is negative. One is positive, one is negative, one is positive, one is negative. And I think if you keep strict with that rule, these factoring lessons, especially the next phases, will get a little bit easier over time. Okay, all right. Let's now go into these final 3 examples, and then afterwards we're done with part 1 of 2 of the video. Then you guys can do practice problems that I'll put on a separate video for you guys to do. Okay. Whoa, Mr. Lucas, I thought that the A value is supposed to be a 1. Okay. Well, I want to put together what we've done in phase 1, and so I want to ask you guys if we can divide out a certain number. Is there a greatest common factor that we can extract out? And the answer to these last 3 is going to be yes. And you're just going to try it out on the calculator. I'll give you this one. If you had said that we can factor out a 6, you are correct. Okay, So let's see if we can GCF, factor out a 6 first. So again, this is like the previous lesson that we did, phase 1. 6 divided by 6 is 1, so this is going to be p squared. 60 divided by 6 is 10p, and then after that 144 divided by 6 is 24. Okay, remember, this is why I like drawing the reverse distribution arrows, because it's kind of signaling, hey, we got to put that 6 back. We're not taking that 6 away. We're not really eliminating the 6. We're just extracting. We're just putting it on the side over here. So this is like reverse distribution. We're extracting a GCF. Okay. Now, this is a 1. Now we can go back to what we've been doing the last 8 examples, okay? What two numbers multiply to 24, but then at the same time add up to 10, okay? So we have 8 times 3. Unfortunately, 8 plus 3 is 11, so we're probably not going to use that. 6 and 4, and I think this will work, okay? 6 times 4 is 24, 6 plus 4 is 10, okay? So then now you can go to your two factors, okay? It's going to be p and p over here, p plus 6, and then p plus 4. Are we missing something? Yes, we are. We're going to drop down that 6, and that's going to be your final answer. Okay. Maybe on your quiz and test, if you're totally unsure of this problem, of your answer, you know, you can definitely check your work. And I want you guys to FOIL first the two parentheses or box, okay? You decide what method you want to do. I'm going to do the foiling method first. So let's just check it just to make sure we're getting the correct answer. P times p is p squared first. And then outer, p times 4 is 4p. Inner, positive 6 times p is 6p. And then last, positive 6 times positive 4 is 24. Usually we can combine these two, so it's going to be p squared plus 10p plus 24. We're not done yet, because now we can bring that 6 to that side and then redistribute that back and see if the answer checks out, okay? 6 times p squared is 6p squared. 6 times 10p is positive 60p. And then 24 times 6 is 144. Let's see if that works out, and yes, it does. Okay, so we came out with the when we checked our work, we came out with the original problem that we started off with. So this is the answer. Some students get subtracted some points because they forget to drop down that 6 that they extracted earlier. Okay, so just make sure you put that 6 back. Okay, this is why I like doing the reverse distribution arrows, because it's telling you, hey, you gotta put that 6 back on the left side. So just be careful with these type of problems. Okay, let's do 2 more, and then after that you can go on to my next video if you want to do some practice problems on your own. Okay, so last 2 for right now. Well, you know, for my thing is, can we see if we can GCF, factor out a 2? And I usually want to try to tackle what's in front of the x squared. And it usually works. Okay. Well, if we factor out a 2, 2 divided by 2 is 1, so it's just going to be 1x squared, minus 28 divided by 2 is 14x, and then afterwards 96 divided by 2 is 48. Okay. Make sure you bring that 2 back on the left side, hence the reverse distribution arrows. Okay, it's a 1 in front of the x squared, so we can do what we've done on this video. What two numbers multiply to 48? 6 times 8. But the thing is, though, we want a negative 14. So remember, we have a positive last term, so we can either have 2 positives or 2 negatives. This is going to work out. So now we have x, okay, x minus 6, x minus 8, or you could put x minus 8, x minus 6, it does not matter. Drop down that 2. Okay. Last one for this video. Let's go see if we can extract some things out first. Let's start with numbers first. So just like on the last video, let's see if we can extract out a 3 or factor out a 3. So then this is going to, 3 divided by 3 is 1. I'm going to take out the 1. M cubed minus 5m squared minus 42 divided by 3, 14m. And I did not leave enough space. We should have put a 3 over here. Okay, so apologies for that. Okay, then think of the variables also. You have 3 m's over here, you have 2 m's here, and you have 1 m here. You can also take out a variable, okay? And I'll put this over here. We can take out 1 m because this has 1 m. This has at least 1 m's. You have 2 m's multiplied together, and you have 3 m's multiplied together. You can at least extract out an m. Okay. All right. If you extract out an m, how many leftovers do you have over here? You have 2 m's left over, so m squared multiplied together, minus you have 1 m left over here, and then you got no m's over here, so now it's going to be minus 14. Just be careful though, on the outside it's going to be 3 and then the m. Okay, alright. Now we can do what we've done on the previous examples. A negative 14, be careful. What two numbers multiply together to make negative 14? Remember, you can have one positive and one negative number. Because a positive times negative is a negative. This is not going to work. We want a negative 5. I think the better one is going to be negative 7 times positive 2. That one is going to add up to negative 5. Okay, so then your final answer is going to be 3m, and then your two factors, m minus 7 and then m plus 2. Okay, I am cutting off this video now, so if you practice problems, I'm going to present some practice problems for you guys to do. I want you guys to go to my factoring phase 2 part 202, and then you'll see some practice problems, and then I'll give you guys the answers to that afterwards as well, after the towards the ending of the video. I'll provide the link somewhere, okay, on the top or in the comments section. All right, thanks you guys.